Continuous. Discrete. The random variable, which takes finite or countable infinite number of distinct values, is called discrete random variable. Consider an experiment where a coin is tossed 2 times. If x represents the number of times that the coin comes up heads, then x is a discrete random variable that can only have the values 0, 1, 2. Some other examples are number of students in different classes, number of members of a family in a city, etc. Probability distribution. Random, continuous. The random variable, which takes any value within a specified range or interval, and can take an infinite number of possible values, is called continuous random variable. Some examples are amount of rainfall in a city over a year, the average height of a group of 25 people, etc. Variable. Probability distribution. A probability distribution is a statistical function that describes all the possible values of a random variable x and its corresponding probabilities that x can take within a given range. This range will be bounded between the minimum and maximum possible values. The probability distribution of a discrete random variable is called probability mass function, and is denoted by f of x. F of x is called the probability mass function if it satisfies the following properties: f of x greater than 0 and f of x equal to 1. F of x is called a probability density function if it satisfies the following properties: f of x greater than 0, f of x dx equal to 1. And probability that a continuous random variable will assume a particular value is 0. Diagram of a probability mass function. Diagram of a probability mass function. Diagram of a probability density function. Diagram of a probability density function. Cumulative distribution function of random variable x. Suppose a bank is having a data of number of customers taking loan month-wise. By dividing the frequency by total frequency, one can find the probability distribution of customers taking loan month-wise. If one is interested to find what the total probability of customers taking loan is by half of the year, one has to add the probabilities up to that, which is called cumulative distribution function of random variable. Thus, cumulative distribution function of a random variable x is obtained by adding the probabilities of a probability distribution. The cumulative distribution function of a discrete random variable x with probability mass function f of x is defined as diagram of cumulative probability distribution. The cumulative distribution function of a continuous random variable x with probability density function f of x is defined as diagram of cumulative distribution function. Properties of cumulative probability distribution. 1. 0 less than equal to f of x less than equal to 1. 2. F of minus infinity equal to f plus infinity equal to plus 1. 3. F of x is non-decreasing function. 4. F of x is a step function and continuous from right. 5. If a and b are two real numbers. Function. Expectation and variance of random variable. The mean e of x of the random variable is the value that is expected to occur per repetition if an experiment is repeated a large number of times. Expectation is the average or mean of the distribution. For the discrete random variable x, expectation of 10 is defined as e of x equal to x f of x, where f of x is the probability mass function of x. If g of x is a function of 10, e of g of x equal to g of x f of x. For the continuous random variable x, expectation of x is defined as e of x equal to, where fx is the probability density function of x. If g of x is a function of x, e of g of x equal to the variance w of x of the random variable x. Measure scatteredness of data is defined by the formula. The variance of the discrete random variable is given by. The variance of the continuous random variable is given by. Properties of expectation and variance. Illustration. Find expectation, variance, standard deviation and CDF of x, when x has the following probability mass function. Also find E of 5x plus 10, and we for x plus 3. Solution. Solution. 1. Find expectation, variance, standard deviation and CDF of x, when x has the following probability density function. Solution. Binomial and Poisson distribution. Binomial and Poisson distributions are discrete probability distributions. Some random experiments have only two outcomes in each trial, success and failure. Binomial distribution describes the distribution of binary data for finite sample, and Poisson distribution describes the distribution of binary data for infinite sample. Binomial distribution. Consider a random experiment consisting of n repeated independent Bernoulli trials, with p the probability of success at each individual trial and q equal to 1 minus p be the probability of failure. Let the random variable x represent the number of successes in the n repeated trials. Then x follows a binomial distribution with parameters n and p, x binomial n, p, with probability mass function as binomial distribution. Real-life examples. Many instances of binomial distributions can be found in real life. Taking a survey of positive and negative reviews from the public for any specific product or place. If a new drug is introduced to cure a disease, it either cures the disease or it doesn't cure the disease. Properties: mean equal to E of x equal to np. Variance equal to W of x equal to npq. Mode. Let m equal to n plus 1 of p. If m is not an integer, mode is the internal part lying between m minus 1 and m. If m is an integer, there are two modes and thus the distribution is bimodal. And two modes are m minus 1 and m. Measure of skewness equal to measure of kurtosis equal to. Illustration. In 10 tosses of an unbiased coin, what's the probability of getting 1.7 heads? 2. At least 7 heads. 3. At most 7 heads. Also find mean, standard deviation, skewness, kurtosis. Solution. Poisson distribution. Poisson distribution is a limiting case of binomial distribution. Here also we consider a random experiment consisting of n repeated independent trials with p the probability of success at each individual trial and q equal to 1 minus p be the probability of failure. Let the random variable x represent the number of successes in the n repeated trials. Poisson distribution is used under certain conditions. They are: the number of trials n tends to infinity. Probability of success p tends to 0. Let np equal to lambda where lambda is finite. X follows Poisson distribution with parameters lambda. X Poisson lambda, with probability mass function as x equal to 0, 1, 2. The symbol E stands for a constant approximately equal to 2.7183. It is a famous constant in mathematics, named after the Swiss mathematician Euler, and it is also the base of the so-called natural logarithm. Poisson distribution real-life examples. Many instances of Poisson distributions can be found in real life. The number of wrong telephone numbers that are dialed in a day. Number of arrivals at a restaurant in a day. Number of calls received in a call center. Properties mean equal to E of x equal to lambda. Variance equal to W of x equal to lambda. Mode: if lambda is not an integer, mode is the internal part lying between -1 and. If lambda is an integer, there are two modes, and thus the distribution is bimodal, and two modes are lambda -1 and lambda. Measure of skewness equal to. Measure of kurtosis equal to. Illustration. In a cafe, the customer arrives at a mean rate of 2 per minute. Find the probability of arrival of 5 customers in 1 minute. At least 4 customers in 1 minute. At most 3 customers in 1 minute. Also find mean, standard deviation, mode, skewness, kurtosis. Solution. Normal distribution. Normal distribution is a type of continuous probability distribution, which is the most common type of distribution assumed in technical stock market analysis and in other types of statistical analyses. A normal distribution is a distribution that occurs naturally in many situations, where 50% of the data will fall to the left of the mean or central value and 50% will fall to the right. Here most data points cluster toward the middle of the range, while the rest of the data is symmetrically distributing towards right and left extremes. Some examples are height and weight of the population, blood pressure, income distribution of people, distribution of marks in an exam, etc. From wherever data of height is collected, it happens that most of the people are of average height. The number of people taller and shorter than the average height people is almost equal, and a very small number of people are either extremely tall or extremely short. If we draw the graph, it looks like a random variable x is said to follow normal distribution if its PDF is given by. Note. Properties. Note. 1. Mu and sigma square are called parameters of normal distribution. 2. If mu equal to 0 and sigma square equal to 1, then the normal variable is called standard normal variable. Generally, it is denoted by ZF of z equal to 3. The graph of normal distribution is bell-shaped and symmetric. Properties. If mu equal to 0 and sigma square equal to 1, then the normal variable is called standard normal variable. The graph of normal distribution is bell-shaped and symmetric. The total area under normal curve is 1. Quartile deviation is 0.6745 sigma. Mean deviation is 0.7979 sigma. Mean equal to median equal to mode equal to mu. 68.2% of the observations will appear within plus or minus 1 standard deviation of the mean. 8. 95.4% of the observations will fall within plus or minus 2 standard deviations, and 99.7% of the observations will fall within plus or minus 3 standard deviations. Area of standard normal distribution. Diagram 1. Diagram 2. Diagram 1. P of less than or equal to 0.5 plus P of 0 less than Z less than A. Diagram 3. Diagram 2. P of Z less than minus A equal to 0.5 minus P of 0 less than Z less than minus A. Diagram 3. P of Z greater than minus A equal to 0.5 plus P of 0 less than Z less than minus A. Diagram 4. Diagram 4. P of A less than Z less than B equal to P of 0 less than Z less than B minus P of 0 less than Z less than A. Illustration. A battery has an average lifetime of 50 hours with standard deviation of 15 hours which follows normal distribution. Find the following probabilities, where x equal to lifetime of battery. P of 50 less than x less than 70, P of x greater than 70, P of x greater than 40. Px less than 70. Solution of problem. Probability table. Credit risk and we are credit risk. We can apply probability concept and different formulas and laws of probability in different practical field. One very important application is credit risk. When lenders offer mortgages, credit cards, any type of loan to different customers, there could be a risk that the customer or borrower might not repay the loan. Similarly, if a company extends credit to a customer, there could be a risk that the customer might not pay their invoices. We are interested to calculate this risk of not repaying any due payment. This is called credit risk. Value at risk. The concept of value at risk is associated with portfolio of an individual or an organization. A portfolio is a collection of different kinds of assets owned by an individual or organization to fulfill their financial objectives. Value at risk is a financial metric that one can use to estimate the maximum risk of an investment over a specific period. The formula to calculate VAR is VAR at 95% confidence level equal to return of the portfolio 1.65. Value of the portfolio. VAR at 99% confidence level equal to return of the portfolio 2.33. Value of the portfolio. This method assumes that stock returns are normally distributed, and is the standard deviation of the stock prices. Illustration. Problem. If the portfolio value is 20,000 rupees, and if 1 month average return and standard deviation is 5% and 6% respectively, calculate daily VAR at 95% and 99% confidence level. Solution. VAR at 95% confidence level equal to return of the portfolio minus 1.65 into sigma into value of the portfolio equal to 0.05 minus 1.65 into 0.06 into 20,000 equal to minus 980 equal to 4.9% of the portfolio. VAR at 99% confidence. Illustration. Exercise 4. Summary. Probability means possibility or chance. Collection of all possible outcomes of a random experiment is called sample space S, and subset of sample space is called event. Two events A and B are called mutually exclusive if A intersect B equal to phi, and exhaustive if the sample space S of a random experiment consists of n equally likely, exhaustive and mutually exclusive sample points and m of them are favorable to an event A, then the probability of event A is given by P of A equal to m by n equal to number of sample point in A by number of sample point in S equal to n of A by n of S. Let A and B are two events and are not disjoint, then the probability of the occurrence of A or B or A and B both, in other words probability of occurrence of at least one of them, is given by P of A union of B equal to P of A plus P of B minus P of A intersect of B. Conditional probability is the probability of happening an event that is based upon a condition. If A and B are two events of a sample space S associated with an experiment, then the probability of simultaneous occurrence of events A and B is given by P of A intersect of B equal to P of A P of B by A equal to P of B P of A by B. A and B are called independent events if PA intersect of B equal to P of A P of B. Random variables is a real-valued function defined over a sample space S of a random experiment. A probability distribution is a statistical function that describes all the possible values of a random variable x and its corresponding probabilities that x can take within a given range. Probability distribution of discrete random variable is called probability mass function, and of continuous random variable is called probability density function. Binomial and Poisson distributions are examples of probability mass function, and normal distribution is an example of probability density function. Assessment test. Please click the above button to check your skills.